Welcome to Spring LIB.
In this exercise, we're going to be talking about circular motion. So before actually solving the problem, let me give you a brief review. All we need to know is that the acceleration of an object that's undergoing circular motion is equal to v squared, v is the speed, divided by r, where r is the radius of the trajectory of the object. Okay, so now we are able to solve the exercise. So what we have is an airplane that's making a circular motion that has a radius of 800 meters. Okay, and just to make clear, the gravitational force is in this direction, the gravitational acceleration. I'm just showing it to show that the circle that the airplane is making is in the vertical, okay, in the vertical plane. And we have the information that the maximum acceleration reached by the airplane is 78.5 meters per second, and the mass of the airplane is 70 kilograms. So in the first part of the exercise, we have to find what is the maximum speed that the airplane reaches. In order to do that, we can just use the formula for the centripetal acceleration, this one here, where you have that v is equal to the square root of the centripetal acceleration times the radius. In our case, the acceleration, which is h times g, 78.5 meters per second squared. I'm going to substitute it here, 78.5 meters per second squared times the radius, which is 800 meters. And this is equal to 251 meters per second. Then, in the second part of the exercise, we have to calculate what is the normal force that someone who's sitting on the on a sit on the airplane will feel when this when the airplane has this speed of 251 meters per second and is at the lowest part of the trajectory, this one here. Okay, so let's draw a force diagram. Notice that there is the gravitational force acting downwards. There's also the normal force that acts upwards on the person and makes the person have an acceleration that points to the center of the circle. The centripetal acceleration always points to the center of the circle. So we have that n minus mg, according to Newton's second law, is equal to the mass of the person times the acceleration. And the acceleration is v squared over r. And our goal is to find n. So I'm going to isolate n here. So we have n is equal to m times g plus v squared over r. So m is 70 kilograms, g is 9.8 meters per second squared, and v, actually v squared over r is the acceleration that we were given, that's 78.5 meters per second. So I have 78.5 meters per second squared. So the normal force is equal to 6,180 newtons, that is equal to 6.18 kilonewtons. And this is the normal force, which concludes our exercise.